Hello, a Rosie math teacher coming at you from my third period accelerated 7th grade math class, working on lesson 10-6, converse of the Pythagorean theorem. So today we're using the a squared plus b squared equaling c squared, just to double check that for sure we are working with a right triangle. We're going to practice with item number 2. A carpenter is measuring a cabinet to ensure the sides create a right angle. In other words, they have not yet showed you this symbol, and they are wanting you to find out, would it definitely need a right angle symbol? If so, then we know that the triangle itself is therefore to be called a what? Right triangle. Okay? So let's determine whether the triangle is a right triangle. How do we do this? We ask ourselves, well, in place of A, let's use the shortest side, which is what?
3.
The 3. So write 3 squared in place of A squared. Plus, what is our next longer side, class? 4. So plus what? 4 squared. Equaling, what is our hypotenuse measurement? 5. So equaling 5 what? 5 squared. All right, we're going to solve this one mentally just so we can show you how you can practice on the calculator to find whether or not it truly equals what it says. Let's do this. What is 3 times itself, class?
9.
9. What is 4 times itself?
16.
16. So 9 plus 16, we know for a fact, equals what amount? 25. So for example, when you plug in more challenging items, in the calculator, you would simply plug in 3 squared plus 4 squared. Your calculator would tell you what number? 25. You could write that number right where I have written it, and then delete all of this from the calculator, clear the screen, and then type in your 5 squared. What would your calculator say when you type in 5 squared? Say it. 25. So once you write that number down, look to see, do my totals match?
Yes.
Yes. If the answer is yes, then you say, yes, this is a right triangle. If your totals do not match, then you say, no, it is not. All right, let's see what hints we might need looking ahead to item number 3. On item number 3, no, it's the same as previously. You're determining whether the triangle is a right triangle. So class, tell me the 2 numbers that you will type in squared into your calculator for the first attempt. 5 squared plus
12 squared.
and whatever number your calculator gives you, write that number down. Then what would you do after you clear the calculator? You would type in what?
13 squared.
And you would write that number down. If those numbers match, you would say what?
Yes.
Yes. If those numbers do not match, you would say no. Is this making sense to you? All right, let's peek ahead at the next item. On item number 4, same thing. They give you 3 measurements. You do the exact same procedure that we've been discussing the whole time. Let's go to number 5. And y'all, number 5 is my favorite because this is my daughter's name and they even spelled it correctly. E-L-Y-S-E. It is the correct way to spell Elise. Don't you dare call her Elsie. No offense. Okay, Elise is building a square raised bed garden with 4-foot sides. She measured the diagonal to be 4 times the square root of 2 feet. Is her garden square? So let's begin, class, by actually drawing a square. Just quickly sketch a scene. Draw a square. This is representing the square raised bed garden. And then it says she has 4-foot sides. So how long is this side?
4.
4. How long is every single side?
4.
4 feet. Do you remember that if you see a math symbol, a little single hashtag on individual sides of a polygon, it means they're the same length as each other. They are congruent to each other. So I'll do that for you. All right, then the next step, she measured the diagonal. Oh, the diagonal. Please draw a diagonal line inside your square right now. It can go either direction. Mine's going to go that way. All right, you've drawn a diagonal. What shapes do you now see?
Triangle.
2 triangles, exactly. Just for sake of our example, we're going to look at the triangle on the lower right here. She measured the diagonal to be 4 times square root of 2 feet. So on that diagonal, what am I writing as my measurement? 4 times square root of 2 feet. We're asking ourselves, will the converse of the Pythagorean theorem prove that our garden is a square? Now you might be wondering, how will the Pythagorean theorem that has to do with triangles help to prove this is a square? Well, because what degree of angles does every side of a square need to have? Every angle needs to be 90 degrees. So would you agree, therefore, that the angle I am now marking in red is what we are trying to prove is a right angle? And if we prove that this is a right triangle, aren't we therefore proving that that is indeed a right angle? And if this is a right angle, the rest of them form right angles with their same measurement of sides and therefore meet the definition of a square. All right, so what would I write for a squared that I will type in my calculator in a moment? Please say it if you know. Give me an A possibility. Okay, let me trace this triangle that we're talking about. I thought you would realize from the 90-degree angle mark, but that's okay. I am talking about the triangle I'm labeling, tracing in green. So what would I type into my calculator for a possible A side? I would do 4 squared, correct, plus what? 4 squared for my B side. It's okay that they're both the same. Equaling what?
8 squared. No.
We don't know the value of this, and we're not even going to try to figure that out. It really doesn't matter. You'll type that in your calculator in a moment. Okay, what am I writing here? 4 times the square root of 2, and that needs to be what? Squared. Class, do you understand? You need to type into your calculator 4 squared plus 4 squared. Whatever number that gives you, when you do it, write that number down. Yes? And then what will you type once you clear the calculator on your second go? 4 times square root of 2 squared. Then write that number down. If those numbers are the same, will you say yes or no? Yes, it is a square because yes, it is a right angle because yes, it is a right triangle. If these numbers are not the same, what will you say? No, it is not a right angle and therefore it is not a right triangle and therefore it is not a square. Do you see all of the reasoning that is happening? Okay, I do want to talk about another item that I've noticed some children were struggling with just a little bit. Number 6, distance. Hey, this is about one of our students who I think even plays baseball, don't you? Or softball. Yep. Okay, the distance between each base on a softball field is 60 feet. So, for example, I like to sketch a scene. Do you guys like to sketch a scene? I find it really helps my brain understand what I am doing. So, I am creating, hopefully, a decently shaped diamond for the softball field, yes? I tried. At least I tried. All right. The distance between each base is what? 60 feet. So I'm going to use my single hashtag to remind you. Terrible drawing I did there, guys. Forgive me. I tried. Each of those lines is intended to be 60 feet long. And then it says, she determines that the distance between home plate and second base, the ones I'm marking in green, home plate and second base, she determines that distance is what amount? 80 feet. Now, what do you notice I have now created on this side?
2 triangle, 1 triangle.
On this side, 1 triangle here, 1 triangle there. Yeah, we only need to look at 1. So what numbers would I put in my online calculator to try to find out if it's a right triangle so that I can know if these bases are at right angles from each other. So basically, I'm trying to prove that this is a right angle here. How can I prove that's a right angle? If I can prove using the Pythagorean theorem, the converse application of it, if I can prove that this triangle is indeed a what kind? A right triangle. If it is, the numbers will work. If it is not, the numbers will not work. This time I'm not writing it down, but please tell me what you would type in your calculator to begin with.
60 squared.
Plus?
60 squared.
Excellent. And whatever number you get, you would write it down. Then you would clear the calculator. And what would you type in next?
80 squared.
And write that number down. If numbers match, you say?
Yes.
Yes, they are right angles. If numbers do not match, you say?
No.
No, they are not. I do want to point something out about number 8. I had a child earlier thought they understood and then they got here and they were getting it all wrong because they were not focused on this word. Choose all of the following that cannot be the measures of the sides of a right triangle. So if you try the numbers in your calculator, 6 squared plus 8 squared, you write the number down. Then you do 10 squared, you write the number down. If those numbers match, you say, yes, it's a right triangle, therefore I don't pick it. If it makes a right triangle, you don't pick it. If it does not make a right triangle, you do pick it. All right, I wish you all well. Please do the very best you can online. Let me know if you have a question.